evening everyone, myself Sravanthi, working as assistant professor in the Department of Data Science and Cybersecurity in MLR Institute of Technology. Today our topic is conversion of NFA with epsilon to NFA. So what are the steps required to convert it? So first, we need to find out the epsilon transitions for the given NFA diagram. Then afterwards, we are going to find out the epsilon closure of each and every state in the given NFA with epsilon diagram. Then after, we are going to find the transition functions, delta 1 transition functions we are going to find. Delta 1 transitions, nothing but what is the formula to calculate the delta 1 transitions is this one, delta dash of q comma a is equal to epsilon closure of q of epsilon closure of q comma a. Nothing but the given diagram. In the given diagram, we are going to write each and every state. If I am having 5 states, for each and every state, we are going to find the delta 1 transitions. Delta 1 transitions. Nothing but actually the given diagram. For example, NFA with epsilon, we are having the 5 tuples. Okay, generally for a NFA with epsilon or NFA without epsilon, whatever it may be, we are going to have 5 tuples. What are the 5 tuples? Q, sigma, delta, Q naught and F. These are the 5 tuples we are going to have. So the given diagram is NFA with epsilon. Now we are going to convert these NFA with epsilon to NFA. Nothing but from the given tuples, we are going to have the new diagram. So nothing but we are going to have new transitions like Q dash, epsilon, sigma dash, delta dash, Q naught dash and F dash. So these are the 5 tuples we are going to find from this given NFA with epsilon. Okay, so that is the thing. So here we are going to find the epsilon delta transitions. Now the updated one we are going to call it as the delta dash. The new diagram, the new transitions which we are going to get, that one we are going to represent it with dash, delta dash. So the step 2 is repeated for each input symbol and for each state of given NFA. Nothing but in our given diagram, for each and every state, we are going to repeat the step 2. That is the meaning. Next, step 4. By using the resultant status, the transition table for equivalent NFA without epsilon can be built. The next one is how to find the final states. The initial states are common and we are going to find the transitions by using the epsilon closure. And next, coming to the only differ is nothing but the final state. How to find out the final state. The given diagram, we are having some final state, that is F. And the next, we are going to get the what are the epsilon closures which are there for particular state Q naught. In that, if I find the F, nothing but the final state in both the cases, if it is matching, that will be the F dash final state. That will be the F dash final state. The same thing. If epsilon closure of Q naught is having F is some final state. If that final state is present in the epsilon closure of Q naught, then we are going to tell that it is a member. Otherwise, simple F is our final state. So this is the meaning. So now what we are going to do to find out the NFA with epsilon to NFA is, the first one we are going to find the epsilon closure of each and every step. And the next one we are going to find the delta 1 transition functions we are going to find. And the next one is we are going to plot a NFA diagram. And the fourth one is we are going to find the final state. So that is these are the 4 steps used to construct NFA with epsilon to NFA. So the first one is we are going to find the epsilon closures. The first one is we are going to find the epsilon closures. Epsilon closure of each and every state we are going to find. Each and every state epsilon closures we are going to find. Epsilon closure of Q naught. Here how many states we are having? Q naught, Q1, Q2 are the 3 states we are having. So we are going to find the epsilon closure of Q naught. Epsilon closure of Q naught. So whatever it may be the state, so the cell itself will be having a epsilon. We are going to assume or we are going to tell that each and every state we are going to have a self epsilon. So nothing but by default Q naught we are having, as it is my starting, I am going to find the epsilon closure for Q naught. So Q naught itself I am having a epsilon, and from Q naught whether any epsilon moves are there. Epsilon is nothing but empty moves. To move from one state to another state, empty moves we are going to find. From Q0 to Q1, there is some epsilon transition is there. So nothing but it is moving to Q1, and next from Q1 again there is some transition to Q2. So Q2, epsilon closure of Q0, epsilon closure of Q0. The next one is epsilon closure of Q1, epsilon closure of Q1. So what is epsilon closure of Q1? I told that epsilon, every state, whatever we are going to find the epsilon closures, the state itself is having the epsilon. So Q1 itself is having the epsilon, Q1. And from Q1, any epsilon moves are there? Yes, from Q1 to Q2, there is a epsilon move, Q2. So epsilon closure of Q1 is Q1 comma Q2. The next, epsilon closure of Q2, epsilon closure of Q2. So check it. Q2 is not having any epsilon moves to other states. So self by default, Q2 itself is having a epsilon move. So that is nothing but Q2. So these are the epsilon closures we have found for the NFA with epsilon diagram. NFA with epsilon diagram. NFA with epsilon is nothing but NFA with empty moves. Okay, so these are the closures. So the next we are going to find the transition function. So the transition function for these diagram, the transition function will be delta, and of the updated one, nothing but we are going to find the transition function for NFA we are going to find. So nothing but it is delta dash, delta dash. So just now we have written the formula here. Delta dash of Q comma A is equal to delta dash of Q comma A is equal to delta of epsilon closure of epsilon closure of delta of epsilon closure of Q comma A. So this is the function I am having. Epsilon closure of delta of epsilon closure of Q comma A. So we are Q is what? The states in our diagram. What are the states? And A is nothing but the input symbols. Here for these diagram, what are the input symbols? Let me write what are the states I am having. 5 tuples I am going to write. Q is nothing but I am having Q0, Q1 and Q2 are the states, set of states, and sigma is nothing but the input symbols. What are the input symbols I am having? 0, 1, 2 are the input symbols, and the next one I am having is Q0. What is my final initial state? Is Q0 is my initial state, and what is my final state? Q2 is my final state. And what are the transition functions are nothing but delta. In the delta, we are going to write the transition functions. Okay, so let me write here delta. What are the states I am having? Q0, Q1, Q2 are the states. A, B, 0, 1 and 2 are the states I am having. 0, 1 and 2. Q0 on 0, Q0, Q0 on 1, pi, empty symbol. Q0 on 2, there is no transition, so pi. So Q1 on 0, pi, Q1 on 1, Q1, Q1 on 2, pi, Q2 on 1, 0, pi, Q2 on 1. There is no transitions on Q0, 0 and 1. Only I have a transition on Q2. So these are nothing but the tuples we have found for the NFA with epsilon. NFA with epsilon. Now we are going to find for NFA without epsilon. Nothing but NFA diagram we are going to find. So let me construct the transition states. So Q is nothing but the set of states. For each and every state, we are going to find the transition function on 0, on 1 and on 2. So like that we need to find for Q1 state on 0, 1, 2, and for Q2 also we need to find on 0 input and on 1 input and on 2 inputs we are going to find. Clear? So let me start. So delta dash of, what is the first one I am taking? Q0. Q0 on, what is the input? 0 input. Epsilon closure, the same syntax I am writing here. Epsilon closure of delta of epsilon closure. Epsilon closure. What is the Q I have took here? Q0, comma, input is 0. Input is 0. So what it is happening? So epsilon closure of delta of, what is the epsilon closure of Q0? I got Q0, Q1, Q2. Q0, Q1, Q2 on 0 input. 0 input. So now what we are going to do? Epsilon closure delta of Q0 comma 0 union delta of Q1 comma 0 union delta of Q2 comma 0. Delta of Q2 comma 0. So what I did, Q0 on 0 input union Q1 on 0 input, Q2 on 0 input. So these are the things I have written. So the next epsilon closure delta of Q0 on 0. This is my transition table, right? From this transition table, I am going to write the inputs. Delta of Q0 on 0. What I am having? Q0 and union Q1 comma 0. Q1 on 0. What I have? Pi. Q2 on 0. Pi. So Q0 union Q0 union pi union pi. So what I am going to get here, epsilon closure of Q0 is what? Epsilon closure of Q0 is Q0 comma Q1 comma Q2. So what this means? So delta dash Q0 on 0 input, it is having Q0 Q1 Q2 Q0 Q1 Q2. So this is for that one. So let me write here delta dash transition function. Q0 on 0, I am having Q0 Q1 Q2. This is for delta dash. Okay. So the next we are going to find for Q0 on 1 input. So what we are going to do here? So delta dash of Q0 on 1 input. We have done Q0 on 0 input. Now we are going to find Q0 on 1 input. Epsilon closure of delta of epsilon closure of Q0 on input 1. In the place of A is nothing but inputs we are going to take. So next, epsilon closure of delta of, what is epsilon closure of Q0? Q0 comma Q1 comma Q2 comma 1. So next, epsilon closure delta of Q0 on 1, delta Q0 comma 1 union delta Q1 comma 1 union delta of Q2 comma 1. I'm going to apply these one input on each and every stage. So next, epsilon closure delta of Q0 comma 1. Q0 on 1, what I have? Pi union delta of Q1 comma 1. I have input 1. Q1 union delta of Q2 comma 1. What I have? Pi. So pi union Q1 union pi. Pi is nothing but empty. Nothing is there. So directly we can write epsilon closure of Q1. Epsilon closure of Q1 is what I am having? Q1 is nothing but Q1 comma Q2. So delta dash on input Q0 state on 1 input, it is going to Q1 comma Q2. Let me write here Q1 comma Q2. Now next we need to find Q0 on 2 input. Delta dash of Q0 among 2 input. Epsilon closure of delta of epsilon closure of Q0 comma 2 input. So what I am having? Epsilon closure of delta of epsilon closure of Q0, what I am having? Q0 comma Q1 comma Q2 comma, what is the input? 2. So epsilon closure of delta of Q0 comma 2 input union delta of Q1 comma 2 union delta of Q2 comma 2. So what I am having? Epsilon closure of delta of Q0 on 2 input. What I am having? Pi. Next, union delta of Q1 comma 2. So what I am having? Pi. Union delta of Q2 comma 2. Q2. So pi union pi is nothing but pi. Pi union Q2 is nothing but Q2. Epsilon closure of Q2. What I have epsilon closure of Q2 is Q2. So on Q0 on 2 input, it is going to Q2. It is going to Q2. Okay. So now I have done for Q0 state. Q0 on 0 input I have done. I am Q0 on 1 input done. Q0 on 2 input is done. So the next state we are having is Q1. Q1 state. The same way, Q1 on 0, Q1 on 1, Q1 on 2. So this is nothing but we are going to find delta 1 transition by taking delta transitions. Clear? So the next one is Q1 on 0 input. So delta dash of Q1 on 0 input. Epsilon closure of delta of epsilon closure of Q1 comma 0 input. So epsilon closure delta of epsilon closure of Q1. What I have? Q1 comma Q2 comma 0. Q2 comma 0. Epsilon closure delta of Q1 comma 0 union delta of Q2 comma 0. So epsilon closure of delta of Q1 comma 0. Q1 comma 0 what I have? Pi. Next union delta of Q2 comma 0. Q2 comma 0 what I have? Pi. So epsilon closure of pi. Epsilon closure of pi is nothing but pi. Q1 on 0 I am having pi. Q1 on 0 I have pi. The same way we will find for epsilon closure of Q1 on 1. Delta dash of Q1 comma 1 is nothing but epsilon closure of delta of epsilon closure of Q1 what I have? Q1 comma Q2 comma 1 input. So epsilon closure of delta of Q1 comma 1 union delta of Q2 comma 1. So what I get? Epsilon closure of Q1 comma 1 is nothing but Q1 union Q2 comma 1. Q2 comma 1 what I have? Pi. So Q1 union pi is nothing but I get Q1. Epsilon closure of Q1. What is epsilon closure of Q1? Q1 comma Q2. Q1 on input 1. It is moving to Q1 comma Q2. Two input. Delta dash of Q1 on input 2. Epsilon closure of delta of epsilon closure of Q1 comma 2 input. So epsilon closure of delta of epsilon closure of Q1 what I have? Q1 comma Q2 comma 2 input. So epsilon closure of delta of Q1 comma 2 union delta of Q2 comma 2. Epsilon closure delta of Q1 comma 2 input is nothing but pi union Q2 comma 2 is nothing but Q2. So epsilon closure of Q2. Epsilon closure of Q2 is what I have? Q2. So on the Q1 on Q2 I am going for Q2. So this is the state it went. So the next I am having is next Q2 state is there. Q2 is the state. Next delta dash of Q2 comma 0. Epsilon closure of delta of epsilon closure of Q2 comma 0. So epsilon closure epsilon closure of delta of epsilon closure of Q2 is Q2 comma 0. So epsilon closure Q2 delta of Q2 on 0, what I have? Pi. So nothing but what it replaces? Epsilon closure of pi is nothing but pi. Q2 on 0, what it is giving? Pi. Next, delta dash of Q2 comma 1. Q2 comma 1 is epsilon closure of delta of epsilon closure of Q2 comma 0. Sorry, 1. Now we are going for 1 input comma 1. Epsilon closure of delta of epsilon closure of Q2 is what? Q2. Delta of Q2 comma 1. Delta of Q2 comma 1. Epsilon closure of delta of Q2 comma 1, what I have? Q2 comma 1 is pi. So epsilon closure of pi is nothing but pi. Q2 on 1 I am having is pi. So the next one is delta dash of Q2 on 2 input. Q2 on 2 input. So what I am having? Epsilon closure. Same thing. Epsilon closure of delta of epsilon closure of Q2. What I have? Q2 on 2 input. So epsilon closure of delta of Q2 comma 2. Epsilon closure of delta of Q2 on 2 is what? Q2. So epsilon closure of Q2 is what? Q2. So Q2 on Q2 I am having Q2. Right? So by using the NFA with epsilon, the tuples, we are going to construct NFA diagram. So now I have plotted all the states with all the inputs. Q0 on 0 input I had done. Q0 on 1 input. Q0 on 2 input is done. Meanwhile Q1 and Q2. All these are done. Now we are going to construct a NFA diagram. Yes, now we are going to construct a NFA diagram based on this delta dash transition function. So what I have delta dash? So what are the states I have? Q0, Q1 and Q2 are the 3 states I have. So Q0 on 0. Q0 on 0, where it is going? Q0 on 0, it is going to Q0 and next it is going to Q1 and it is going to Q2. On which input? On 0 input. On 0 input, it is going for Q0 on 0 input, it is going to Q0, Q1, Q2. I plotted it. Next, Q0 on 1 input. Q0 on 1 input, where it is going? Q1 and Q2. Q0 on 1 input 0, 1. Q0 on 1, it is going to Q1 and Q2. Next, Q0 on 2 input, where it is going? Q2, 0, 1, 2. Right? Now Q0 is completed. So the next Q1 on 0, pi is nothing but it is not having empty. Okay, next dead state, it's like Q1 on 1, where it is going? Q1 on 1, it is going to Q1 and it is moving to Q2. Next Q1 on 2, it is going to Q2. Q1 on 2, it is going to Q2 state. Now Q1 is also completed. Next Q2 on 0 and 1, it is going for dead state. Nothing but empty. Nothing is there. So I just kept it with pi. So the next is Q2 on 2, it is going to Q2. So on 2 input, it is going to Q2. So this is the NFA diagram. So now we need to find out what are the initial states and what are the final states. So by default, the first state itself will be the starting state or initial state, that is not changing. Now coming to the final state. So what is final state? What we have written here? F dash is equal to F union Q naught. F union Q naught. See here, F dash is equal to F union Q naught. So what is F from my NFA with epsilon diagram? F is pointing to final state. F dash is nothing but, for the NFA diagram, F dash is our final state. Okay, so we are moving from one to another. So that's why delta to delta dash, F to F dash. So F is nothing but the final state that is having is Q2 in my NFA with epsilon. So Q0. So what are the epsilon closures I have found in the epsilon closure? In the epsilon closure, if I find F nothing but F is nothing but Q2. If I find Q2 as the final state in my epsilon closure of Q0, then that will be our final states. Then that both the states are final. So once again, so Q0, here I am having Q0. In the Q0, if I find Q2 as my final state in epsilon closure of Q2, in epsilon closure of Q0, if I find Q2 as a final state, then I'll be having the final states are Q0 comma Q2. If suppose, if I don't find in the epsilon closure of Q0, this Q2 is not found, then the final state will be as it is Q2. But here in this diagram, in this NFA with epsilon diagram, I am having here Q2. Nothing but the final state of NFA with epsilon is found in the epsilon closure of Q0. So now the final states are Q0 and Q2. Q0 and Q2 are the final states and the starting state is Q0. So let us write what are the tuples I have. Q dash is equal to Q0 comma Q1 comma Q2. So the next sigma, nothing but number of input states, 0, 1, 2. 0, 1, 2 are the inputs. Next I have is delta dash. Delta dash is completed. Now what is the initial state? Initial state is nothing but Q0 dash is nothing but Q0 is my initial state. So final state, what is my final states? Q0 comma Q2 are the final states. So this is for NFA diagram. So the given NFA with epsilon, we are converted to NFA. So this is nothing but NFA. This is NFA with epsilon. So this is about NFA with epsilon to NFA. Thank you.